Greetings everyone! This month I'm coming to you live from my new home in Austin, Texas, my third and hopefully final location this year, at least until 2018. I'm excited for this month's November Math Fix, so without further ado, let's get started.
Today's Math Fix is brought to you by G.SRT.5, which asks students to use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures. Let's take a look at our problem today. Students are asked to imagine that their mother needs a ladder in order to hang lights on the roof in preparation for the holidays. Given limited information, students must determine the height of the shortest ladder they should purchase to reach the height of their house. Where might students start with this? Let's jump in. Students might initially struggle with the fact that no information is given as to the height of the car. This leaves the problem scenario somewhat open to interpretation. Is the car a sports car, a sedan, a station wagon, an SUV or minivan, or perhaps even a truck? You might suggest that students estimate the heights for a range of cars. It is probably reasonable to assume that a sedan might have a height of around 4.5 feet, whereas a truck or SUV might be closer to 6 or even as tall as 6.5 feet. Once students estimate the heights, they can go about using similar triangles, as the standard suggests, to calculate an approximate height for the house. If we use the lower estimate of 4.5 feet, by similarity, we get an approximate height of about 17 feet for the height of the house. In the context of this problem, this would make sense. Since one story is usually 10 to 12 feet high, this could be a one-story house, perhaps with an attic accounting for the little bit of extra height. However, the question asks for the shortest possible ladder. So to be safe, we need to estimate for the tallest possible car. So, using 6.5 feet, we get an approximate house height of 24 feet. Checking to see if this makes sense in the context of the problem, this could be a two-story house with a flat roof. One thing to keep in mind, however, is that a ladder cannot lean straight against the house, so students might want to use the Pythagorean theorem to calculate the hypotenuse of a triangle formed by a 24-foot house and allowing a couple of feet away from the house for the ladder to rest on an angle. With these numbers, the few feet do not really change the value of the hypotenuse that much, so a 25-foot ladder might be sufficient. One extension to this problem might be to ask students, given the other dimensions, how far the car could be parked away from the house to still get a reasonable value for the height of the house. They would then have to keep in mind the length of a driveway or perhaps even a street if the car was parked across the street.
And that's this month's Math Fix, folks. As usual, we love hearing about what you're up to in your classroom, so don't hesitate to share with us your take on this month's problem. Remember, we'll be taking a break for the month of December, but we'll be back in the new year. Until then, we wish you and yours a happy and healthy holiday season.